This is section 3.2, part 2. Least squared regression. Last section, or part 1, we discussed the regression line. We discussed what a residual was. Residual is actually the actual minus the predicted, or what's left over. One of the first principles of data analysis is to look for an overall pattern and for striking departures from the pattern. A regression line describes the overall pattern of a linear relationship between an explanatory variable and a response variable. Residual plots are what we're going to talk about today. And basically, a residual plot helps to determine if a linear model is appropriate for the data. So first thing we're going to do is we're going to write down the definition of a residual plot. So it is it looks like a scatter plot. So a residual plot is a scatter plot that plots the residuals on the vertical axis and then the explanatory variable on the horizontal axis. So when you see a residual plot, this was an example of a residual plot here. So this was the average income and fertility rate that we had discussed in an earlier section. And so if you look, the average income is your horizontal axis, and it is in the residual plot as well. And then instead of having the response variable, you actually plot the residuals. And so your residuals, are gotten from subtracting the actual minus the predicted. So for each of these points, they've actually gone through and found what the residual is. And if you look, you always have a 0, and then you have these points here would have a positive residual, and these points underlined would have a negative residual. And so that's basically what a residual plot looks like. So we're going to take a look at how do you interpret a residual plot. Like, what do we get from these? Okay, so determine whether the regression model is appropriate. Look at the residual plot. If there is no leftover curved pattern in the residual plot, the regression model is appropriate. If there is a leftover curved pattern, consider using a regression model with a different form. Instead of using linear, use another form. So let's look at these two examples we have over here. Okay, first of all, we notice with this first scatter plot, look at that regression line. That does not fit the data very well at all. In fact, if you look at this data, it almost has, it doesn't look linear to begin with, okay? So this doesn't look linear. The original scatter plot showing the relationship between average income and fertility rate, from the beginning, from the get-go, it doesn't look linear, okay? So if this is your line of best fit here, that's not a really good explanation of this data. So if we take and we use the residual plot for that information, what you're seeing here is a curved pattern. So anytime you see a curved pattern in the residual plot, that means that a linear form is really not the best fit, okay? So what can you determine from the residual plot? The curved shape of the residual plot, the curved shape of the residual plot indicates a linear form, is not a good match. So that is what the residual plot kind of helps us to determine. Okay, so that was the first example. So this was the residual plot, the scatter plot. This is the residual plot that went with it, and it kind of corroborates what we originally thought. That doesn't look very linear from the beginning. So let's take a look at the second one. This one was miles driven and the price. This was when we were talking about the vehicles. So if you look at the linear regression line, or the line of best fit, it goes through the data pretty well. If you look at the scatter plot, the residual plot, if you look at all these points, they're just scattered about. There's no pattern, and that's what you're looking for. So what can you determine from this residual plot? Okay, so because residual plot has randomly scattered points, because residual plot has scattered or randomly scattered points and no curve. You don't see any curve. And no curve. A line is a good form. Line is a good form. Okay, so that's what we get from this residual plot. This is what you're looking for, to say, hey, a line is a good form. This, whenever you see any kind of curvature, the line is not a very good form. And again, if you look at the horizontal axis is miles driven, but the vertical axis instead of price, as in the scatter plot, it's actually your residuals. So in this residual, you always have 0 in the middle. These above here are going to be positive. These below the line here are negative, and you're finding the actual difference and you're plotting those. Now, good thing is your calculator, I'm going to show you how to put this in the calculator and it'll do the residual plot for you. All right, so we got one more example. It says, is a linear model appropriate to describe the relationship between the weight in carats and the price in dollars of round, clear, internally flawless diamonds with excellent cuts? We calculated a least squared regression line using x's weight and y's price, and we made the corresponding residual plot shown. Use the residual plot to determine if the linear model is appropriate. So see what you guys think about this. Does that look like randomly scattered, or do you see some kind of, to me, it kind of looks like it's sort of a U-shape, okay? Because there is some pattern like that, the linear model is not really appropriate, okay? So let's just write, because there is a U-shaped pattern, the linear model relating price to carat weight is not appropriate. So it's basically just saying the linear model would not be appropriate, okay, for this particular example, because we see like that U-shaped. Okay, so the next thing we're going to do is we're going to talk about, I think you guys understand what a residual model does and what are you looking for to show strong linear form. So what we're going to do now is we're going to go, when you make a residual plot in the calculator, you're going to start off by going through the entire process of finding the least squared regression line, okay? And then it's automatically going to calculate this for you. So what I'd like for you to do is stop for just a moment and go and type that data into your calculator. Okay, so hopefully you have got your body weight, and what this is comparing is body weight versus backpack weight. So the more you weigh, you know, you're comparing how much backpack weight that you can handle. So I've gone through and I put the data in list 1. So then we know we're going to go to make a scatter plot. You hit second y equals. You want to turn this on. It is on scatter plot, list 1, list 2, all that's good. Hit graph. Zoom 9, zoom stat, whoopsie, let's see, zoom stat, and there's your scatter plot. Whoops, I already found the line of best fit. So let's remind ourselves how we find that. Let me get that out of there. So to find that line of best fit, you're going to hit stat, you're going to go over to calc, and you're going to go down to number 8, and it is going to calculate that line of best fit for you. So number 1 says to calculate the equation of the linear regression line. So there's your y-intercept. So it's y hat, don't forget it's a prediction line, equals 16.26 plus 0.091x. Okay? So you either need to type that in, or hopefully you remember, if you go to y equals and you go to vars and you go down to statistics and you go over to equation, it just transfers the equation for you. And there we go. We have the linear regression line, or least squared regression line, graphed. Okay, So now let me show you how to make the residual plot. So you have to go through, find the equation, graph it. So now to make the residual plot, you're going to hit second y equals. Your plot 1 needs to be on, scatter plot. You want that, remember, the L1 is still your explanatory variable. Now you want to change that to residuals, the y. So the way you get there is you hit second stat, and here's residual right here. The way I got that was second stat. So instead of your y list being L2, you want it to be a residual. Second stat. Hit graph. Okay, so we need to hit zoom 9. And there we go. There's my residual plot. Okay. So what you can do is hit trace, and here in just a minute it's going to ask us on the, and if you arrow over, it goes to every single point, and it actually tells you down here the x and the y. And so that would be the best way. If I think you were asked to graph a residual plot, I would do it. Is I would just take your data, make a scatter plot, and then go through, like I said, we did second y equals, and the only thing we changed is the y is the residuals, okay? And so what we're going to be asked to do on the next page is to actually graph this thing. Okay, and it does say, what does the residual plot indicate? We'll write that on the next page. Okay, so what we're going to do now is we're going to actually come over here, and we are going to graph the residual plot correctly. You do use the trace feature, and so what you want to do here is if you go back and you use the trace feature, you can kind of see that, you want to put 0 in the middle, and I guess you can draw a line here. So we'll have 0 in the middle. And then we are going from, let's see, if we hit trace, let's see what we got. All right, so our highest point or residual is at like 3.75, and our lowest residual, I'm looking at how to graph the y-axis, is negative 1.6. So on this one, you can just do 1, 2, 3, 4. These are the residuals. And then negative 1, negative 2, negative 3, negative 4. Okay. And then we've got your body weight here. So we do want to label this. This is body weight. And these were the residuals. And if you hit trace, I guess we need to go label the body weight. So if we look back at the table, it goes from around 100 up to 187. So maybe let's graph from 100. We could go up by tens. 120, 130, 140. And then we're going to go back. So then once you get this drawn out here, I want you to go back and trace. And I want you to plot all those points. We'll go up to 200. So I'm going to stop it. Go trace your residuals and plot those points, and then we'll compare our graphs. Okay, so as I hit trace, and I went from point to point, I just looked to see, like this point here is 120, negative 1.2. I want 120, negative 1.2. So hopefully that is what your residual plot looks like, okay? What do you think this residual plot says? What does this tell you about the appropriateness of a linear model? Since the residuals are randomly scattered, do you agree those look pretty randomly scattered with no curve pattern? The residual plot indicates that a linear model is appropriate to compare body weight and backpack weight. Okay, so we're going to write that down. Since the residuals are randomly scattered with no curve pattern, the residual plot indicates The residual plot indicates that a linear model is appropriate, that a linear model is appropriate to compare body weight and backpack weight. Okay, so when you have a residual plot, that's what it helps you to determine. Okay, the next thing we're going to talk about is the role of S and R squared in regression. So we talked about what R was. R was correlation, and correlation was how, strongly a linear pattern it's making. Remember, a correlation, or R value, went from -1 to 1. If it was close to -1, it meant it was a negative correlation and very, 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 followed a linear regression really tightly. There was a strong linear regression, or if it was +1, same thing except a positive. And if it was close to 0, it meant it did not follow a linear pattern very well. So let's fill in the blanks here first. Let's see, and I already have this done, so we'll just kind of. A residual plot determines if the least squared regression line is linear, okay? The role of S, so what S stands for is the standard deviation of the residuals. So anytime you see S, it's the standard deviation of the residuals. So think about that. You've got your residual values and you're finding the standard deviation. And R squared is called the coefficient of determination, and it tells us how good a fit our line and how good our prediction will be. So we're going to talk about those two things, standard deviation of the residuals and R squared. The standard deviation of the residuals, which is S, measures the size of a typical residual. That is, S measures the typical distance between the actual Y values and the predicted Y values, because that's really what a residual is. So the value is most often provided and not calculated. Most of the time you don't have to find it. They give it to you and you've got to interpret it. So we're going to talk about how do you find it. Well, this is the formula. So S equals the square root of the sum of the squared residuals. So that's how you find your residual. Actual minus predicted. You square it. And it's the sum of all of them and then divide by n minus 2. So mathematically, that's how you would find it. So let's do an interpretation. Okay, so using the Ford F-150 data, if S is 5,740, interpret what S means. So what that means is the Ford F-150 is typically about $5,740 away from the price predicted by the least squared regression line, with X being the miles driven. So that's actually the standard deviation of the residuals, okay? But if you are asked to interpret what it means, don't forget you need to put it in context. So you're going to say the Ford F-150 is typically about whatever the S is, 5,740, away from the price predicted by the least squared regression line, with X being miles driven. So that's how you would actually, you would actually interpret that. So anytime it asks you to interpret this S value, don't forget that's the standard deviation of the residuals. And the residual for this one would be the actual price versus the predicted amount. Okay, so now we're going to talk about what the coefficient, or R squared, is, and that's called the coefficient of determination. So R was the correlation, all right? And so now we're going to talk about what R squared is. And both of these things, we will find on the calculator. So what R squared does, it actually measures the percent reduction in sum of squared residuals when using the least squared regression line to make predictions. It's the percent of variability in the Y that's actually accounted for by the least squared regression line. So in many AP questions, they may give you R squared and they'll say, hey, interpret what this is. So it is the percent of variation in the response variable that is accounted for or by the explanatory variable. Okay, so the variables you need to put in context. So R squared does not have a unit of measure and it's listed as a percent. So let's look at an example of how you would interpret it. It says interpret the coefficient of determination for the Ford F-150 if R squared is 0.66. So you would say, okay, about 66% of the price of a Ford F-150 is accounted for by the miles driven. So you always would change that to a percent and say about 66% of the price. That's the response variable. The price of the Ford F-150 was the response, and it's being accounted for, 66% of the price of it is being accounted for by the miles driven. So you're like, all right, what's the other 34%? Well, the other 34% of the price could be due to other factors such as condition, color, age, features. Okay, so that's what the R squared is. It's coefficient of determination, and that is how you would need to put it in context, and this is how you would actually say, what does it mean or what's the meaning behind R squared. Okay, and then the last thing we have is one more example. Let's take a look at it. It says, in this problem, it says the scatter plot shows the handspan and number of starburst candies, grabbed by each student in Mr. Tyson's class, along with the regression line. For this model, S is 4.03 and R squared equals 0.697. Interpret the value of S, interpret the value of R squared. Okay, so this is the scatter plot, okay? And so if you have to interpret what does S mean? So S is 4.03. So you would say the actual number of starburst candies grabbed is typically about 4.03 away from the number predicted by the least squared regression line, with X being the handspan. So that would be in the interpretation of that. It is in context with the handspan and number of starburst grabbed. So again, that S, the 4.03, the standard deviation of the residuals. That's what S is. It's the actual number of starburst candies, or the actual number of starburst candies grabbed is typically about 4.03 away from the predicted by the least squared regression line with X equals handspan. Okay, so now let's interpret what R squared is, the coefficient of determination. So we want to change that to 69.7. So you would say, hey, in my words, and then we'll write it out, is 69.7% of the amount of starburst candies grabbed is determined by handspan. So about 69.7% of the number of Starbucks candies grabbed is accounted for by handspan. So that's what it is. Like, how much is this determining this? And it's in a percentage. And that is how you would interpret R squared. Real quick, let me remind you about one thing. When you are making a scatter plot, you want to go to mode, and you want to go down here, and you do want to turn on your diagnostics. So make sure they're on. And then what happens is when you go and you calculate that line of best fit, not only does it give you the line of best fit, it also gives you your correlation, your R value, and it gives you your R squared, or your coefficient of determination, okay? So make sure you have your diagnostics on, and when you enter your data, you're able to find that on the calculator. Okay, there is one more section, so we're going to be doing 3.2, part 3 next.